Okay, we are going to continue solving exponential equations. We started this in class on Monday, so we will continue with some more examples today. And we're going to go ahead and just follow these 3 steps for solving exponential equations. First of all, how do you know that it's an exponential equation? They have an x in the exponent position. So that's like number 1 here. We have 2 to the x power equals 256. So that has an x in the exponent position. And same with number 2, 5 to the 2x power equals 625. So you're solving for a variable that is in the exponent position. And when that's the case, you're going to want to solve the equation using these steps. So we're going to start off by rewriting the left and right side of the equation so that they have what's called the same base. And what I mean by the same base is they both have the same number in the base position. For example, this 2, that's your base. And your 5 in this case would be your exponent. But we want to make sure that both the left and the right side of the equation have the same base. And you can't start solving your equation until they have the same base. So we'll go ahead and do that for this first equation. We're looking at the left side of our equation. We've got a base of 2. And the right side is just a whole number. There's no base. So we're going to rewrite 256 so that it has a base of 2. So one thing you can do is just continuously multiply 2 times itself until you get to 256, and then count how many 2's you have, and that would be your exponent. So I could do 2 times 2. That's going to give you 4. 4 times 2 is going to give you 8. 8 times 2 is going to give you 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128, and then 128 times 2 is 256. So I could say that 256 is 1, 2, 3, 4, 5, 6, 7, 8, the same as 2 to the 8th power. So I'm just going to rewrite this as 2 to the 8th power. And then just bring down what's on the other side of your equation. The next thing you're going to want to do is set the exponents equal to each other. So we'll take our exponents and we'll set them equal to each other. X and 8. So x equals 8. Sometimes you'll have to then solve for x because you'll be left with an equation that doesn't give you the exact value for x. But in this case, we're left with just x equals 8. So that's our solution. And then we're going to check our solution. So we can take this 8 and substitute it back into the original equation. So instead of 2 to the x, I'm going to put 2 to the 8th, and I'm checking, does that equal 256? And we can use Desmos, 2 to the 8th power, and that does equal 256. So I know that I did get the correct answer, and x really is equal to 8. All right, so for number 2, let's go ahead and start. We are going to rewrite the terms on both sides of the equation so that they have the same base. So my left side already has a base of 5. So I'll rewrite the 625 to have a base of 5. So I can just continuously multiply 5 times itself until it gets to 625. So I can see that 5 to the 4th power is 625. So I can rewrite that side of the equation to have a base of 5 by making it 5 to the 4th power. So I just rewrote that 625 so that it has a base of 5. And now I'll just bring down the left side. And then my next step is to set the exponents equal to each other in order to solve for x. So I'm going to set the 2x and the 4 equal to each other. And the reason I'm going to do that is so that I can solve for x. So my x, I'm going to divide by 2, and I'll get x is equal to 2. And then you're going to want to check your answer by substituting it in for the original x value. So I would have 5 to the 2x. 2x is the same as 2 times 2. Does that equal 625? Is that a true statement? So I can check 5 to the 2 times 2 power. I mean, you could take a shortcut too and just multiply 2 times 2 to get 4. That's the same thing. I can see that equals 625. So I did, in fact, get the right value for x. X really is 2. Okay, so we'll just continue using these same 3 steps over and over for numbers 3 and 4. And I'm going to go ahead and add a page here so that I can get a little bit more space for number 3 and 4. So let's see, it looks like it's not going to let me add a page. So I'll try to make it fit. So on the left-hand side, I already have a base of 3. So I'm going to rewrite my 243 to have a base of 3. And you can use a calculator to help you do that if you're not sure. Just keep multiplying 3 times itself until it equals 343. Or sorry, 243. And there you go. So 3 to the 5th power is equal to 243. So instead of 243, I'm going to write 3 to the 5th power because they're equal to each other. And then just bring down the other side of your equation. Now that I have the same base, I can set my exponents equal to each other. 1 minus 2x equals 5. And then solve for x. So we can subtract 1 from both sides. And then divide by -2. And we'll get, if we do 4 divided by -2, you get x equals -2. All right, so we need to check, is 3 to the 1 minus 2 times -2 power, is that equal to 243? We don't know. We're going to check. So I'm going to plug in 3, and then to my exponent is 1 minus 2 times -2. And I can see that that really is equal to 243. So I got the right amount for x. That's true. And finally, our last one is number 4. And we already have the same base. So we can skip that first step. We don't have to change anything. We can just set the exponents equal to each other. So we'd have 2a equals -a. And then some of you, this kind of confuses you when there's not a number in front of the variable. It's like an invisible 1. So I could add the 1a to both sides. And then on my right side, I have 0 now because those cancel out. And I could divide by 3, and I'll get that a equals 0. So is that a true statement? Is a equal to 0? And if I substitute a 0 right here for a, I'll get 3 to the 0 power, because 2 times 0 is 0. And then 3 to the negative a power means 3 to the 0 power. So yes, it's true because I would end up with 1 equals 1 or 3 to the 0 power equals 3 to the 0 power.